Jason from 12 Volt Shed, here today to talk about our little trusted Coromal Compac. The Coramal's got a pretty basic wiring system in it, and we'd like to upgrade it so that it's got a bit more flexibility, and we're going to add in some solar and DC-DC. So today we'll just run through the basics of how we're going to go about it, and you should get something out of this, even for people that are a bit more advanced, and even your basic beginners on basic how to put a simple power board together. So let's go and have a look. So as you can see here, the current situation's far from ideal. The battery's tucked away in the corner here. We've got a pretty big mess of cables, some automotive fuses, a little Auscharge battery monitor, but we have got a bit of space in the corner here where we could improve things. So this is what we're going to look at doing a bit of an upgrade here. So basically we want to put a little power distribution board in this space in here. So the first thing I'm going to do is get a bit of cardboard and cut it out to the size I think, and the cardboard becomes my template for the unit. So as you can see, I've cut this cardboard out and I need to trim a bit off. It's obviously a little bit too big, so I'll do that until I get my size right, until that fits in there nicely, and then that becomes the template for my piece of plyboard. So we're now here in the shed, and now I'm going to make up my board. I've been down to trusty good old Bunnings and bought some 7mm ply. I'm not mounting a heck of a lot of weight off it. I didn't need marine grade ply because it's in a boot where it won't get exposed to the weather. So just a little bit of ply, and I've grabbed some marine style carpet that we'll wrap that board in. Just something to keep in mind, just remembering that the carpet's a little bit thick, so when you wrap the edge of your board that you create, and again using our template that we've already created, that will make that a little bit thicker. So just factor that when you're designing your template. Righto, so I'll go and cut the board and give it a carpet, and we'll get the board done. Okay, so here we have our board now made. So as you can see, I've carpeted around the edge. I've just used some spray fix, some Bond spray fix, again available at Bunnings. It was about $12 or $13. I didn't need a big can because only a small board. I have put a cutout on the top of the board, and that'll allow cables to pass through into the Caravan, and we'll put a hole in the van for access to cable, and that'll become the basis of our mounting. And now it's just a matter of positioning everything where we want to position it. So we'll sit now and play what I call the place the components jigsaw puzzle, and work out the best way we can run cables and the nicest layout that we can get. It is a pretty compact little board this, so being a 401 Coromal Compac, I don't have a lot of room. Tower weight on this van's 750, so it's we call it affectionately the chubby cubby, because the miss is a little bit chubby and it's our cubby. So yeah, so all right, let's have a look at the board. So one of the biggest things we need to look at is what we've currently got and what we want to achieve out of doing this electrical work on our van. I have a Coromal Compac 401. It's only a small van, but it's pretty indicative of a lot of vans on the market. It's an older van, so it's fairly simplistic in its wiring. It's got a 7-pin flat trailer plug, goes over to a distribution board with a couple of fuse boxes. It's got a fridge, it's got one cigarette socket internally for the entire power of the van, and some LED lights throughout the van, all powered by a little battery here. The install's very much manufacturer based. It's probably been modified a few times over the years by various owners, but I really want to improve the amount of distribution points in the van, so I want to fit extra SIG sockets and USB sockets, so I need to add more 12 volt circuits. I'd like to be able to have solar input, either that be from a portable or a roof mounted. It is a pop top, so I'd have to be careful about the weight of any solar panel on a pop top, but I can put a thin film solar panel up there. So I'd like to build in the functionality to be able to do that. I'd like the ability to add another battery. Now, whether that be from the vehicle or a portable battery, and I'd like the ability to select between the two. At the moment, I'm very much limited by space, weight. Again, it's a compact van. So the ability to add in a second battery or to connect to the vehicle would be a fantastic advantage. It would double my battery capacity on trips. So that's what I've currently got. Very, very commonly in vans, the fridge is often powered by the reverse, or you'll see an auxiliary circuit on the trailer plug. That's basically wired directly to the fridge, so that power is provided to the fridge when the trailer plug's connected. Then they often have a wire going to the battery with a diode positioned in there, so that at no time can the fridge be run from the battery. But when the trailer plug is connected, it can charge the battery and run the fridge. I don't really like this setup. It's a very small cable. These fridges pull 11 to, I've seen some of the older ones pulling up to 20 amps. But even at 11 amps for a little cable, it's a big ask and not very efficient. So I'll be looking to redo this, put a low voltage disconnect in place, and give myself the ability to run this fridge from either the vehicle via a heavier cable or via the battery from solar. So I'll be changing this up, but that's very common. Just keep that in mind if you've got a Caravan install. All right, well, let's now get rid of this and let's have a look at where we want to be. Righto. Okay. Well, again, excuse my drawing skills. I was far from a graphic designer or an architect, but I'm going to talk you through this. I'll get my trusty camera lady to get some close-ups of this as we talk through it. But essentially, I want to be able to utilise, obviously, the battery in the van to power the circuits that were in the van. I've taken that tangled mess through a nicely neat plug now, and I'll feed that back through that plug. That's my little white connector you'll see in the video, where I'll show you now. Okay, so that'll go through the plug. That is the original factory wiring in the van. So that whole circuit that powers the existing things in the van will work as normal. I now have off the top of that fuse block here the ability to add 4 more circuits. I will also add in a couple more larger MIDI style circuits in the top to give me a bit of future proof. Keeping in mind, this is all protected by my low voltage LVD, low voltage disconnect. So any power coming up to that from either battery is protected by the low voltage disconnect. So if I leave a light on, it's not going to matter. That will disconnect any power coming to any of the circuits in the van. The van is basically powered through a 4-pole, a Blue Seas 4-pole, 4-position switch that has 3 terminals on the back of it. Battery 1, battery 2, and output. So that 4-pole switch gives me the ability to isolate all power from the van. I can switch it over to battery 1 and power the van from the battery in the van. I can switch it over to battery 2 and power it. At this stage, that will be via an Anderson plug. Now, that Anderson plug could connect to my auxiliary battery in the vehicle. It could be a spare battery I have in a battery box. It could be a mate's battery. It wouldn't really matter. It just gives me the ability to switch over to another battery. But this switch has a special ability to join batteries 1 and 2 at the same time. Now that comes in handy with when I add my solar via my DC to DC. I will run, keeping in mind this Anderson plug here is my second battery or auxiliary battery in the vehicle, but I will run a whole new circuit in my vehicle off the alternator. So this will be alternator positive, and that will come to the back of the vehicle and connect to a separate Anderson plug that will then go into the DC to DC. Okay, that will then step the voltages up and power that battery. It could charge that battery if I had a second box. But more importantly, when I add my solar onto the van, when I'm producing solar, if my battery's full, I can switch this over to battery 2 and power or charge the battery as the auxiliary battery in my vehicle as well. Or conversely, switch it over. I've had a really bad week of solar and bad weather. I can switch this switch to battery 1 and 2 and use power from both battery sources, or I can just have it as the one battery. It just gives me great flexibility. Yeah, it's a bit of a pain in the wiring and there's a bit of work to be done, but once it's done, this will give me a very flexible system. So feel free to copy it, feel free to use it. I'll give you feedback on how it all works, but this is a good system and it should work very nicely. It's got all the required elements: flexibility, protection, DC to DC's future-proofing me. This DC to DC does have a lithium curve if I ever want to put lithium in the van down the track. So, and it'll make the whole thing neat. I've added in here, obviously, on the negative circuit, that little shunt where all of my loads, all of the positives, the negatives from this, I should say, the negatives, will go to that shunt. That is a little, I can't draw the Bluetooth logo, but it's got a module that allows me to connect via Bluetooth and I can monitor and measure all of my loads. I'll point that out on the board. But that's the basics, that's what we want to achieve. And we'll go and make all the board now and fit it all up and fit it to the van, and we'll have a play and we'll come back right at the end and I'll let you know how it all goes. Wish me luck. So I've now finalised my board design and my layout. As you can see, I've played around with a fair few different ways. There's a lot of effort and thinking has gone into this, trust me, and there's a bit of method to the madness in all of this, and I'll walk you through that. But basically, I'll break it down very quickly, component by component. For this build, I'm using the brand new GSL Electronics 30 amp DC to DC with solar. This is a new unit. This is the first time build for me with one of these units. This is an Australian made product. It is very, very compact. As you can see, for a 30 amp unit, it's really good in size. GSL being an Australian manufacturer, and especially during this time of COVID, I'm really trying to support Australian manufacturers. And I really want to have a play with this and see how it goes. So the team at GSL have been generous enough to send me one and a little battery monitor, so I'll do a separate product review on the GSL, but that's primarily been selected because it's so compact. I've positioned it so that the LED displays in this unit can be seen on the outside of the board. One of the big features, and we'll go through this on our little whiteboard lesson later on the setup, is this Blue Seas. I use Blue Seas, it's marine quality. It's essentially a 3-position, 3-pole with 4 positions. So it has battery 1, battery 2, and output. Surface mountable, or you can flush mount it in behind a panel, put your cables in behind. This switch enables me to switch between battery 1, battery 2, or have battery 1 and 2 connected. So what that's going to enable me to do is power the van from the battery in the Caravan by selecting battery 1, and I can charge from solar to that battery, or I can move this over to battery 2, connect my Anderson plug at the front of the van to the car, and the auxiliary battery in the car can now power the Caravan from that battery. So it gives me a bit more flexibility between the 2 batteries that I have in my various systems. Alternatively, I can switch between both and bring power in from both, or if I've got full batteries and I've got solar, I can solar charge both. So that gives me a lot of flexibility. So that's been an integral part of the build. Circuit breakers, obviously, and I always put circuit breakers on all the circuits to protect the cable and to protect the investment of the equipment that I'm using. And I always use good quality circuit breakers. These are Bussmans. Again, I always like to use Bussman because they're American made product and they don't get hot if I put a lot of current through them. So being a 30 amp DC-DC, I'll make sure that I fuse it and circuit break it the appropriate size and that I use good quality gear. There's an old saying, the poor pay twice, and I really don't like the cheap circuit breakers. Low voltage disconnect. So whichever battery is powering this van, all of the power will come through a Victron 65 amp low voltage disconnect. So that is protecting my battery investment. I've got good quality batteries, you know, they cost $300 to $400 or $500, some good batteries, and I don't want this system to destroy that battery. That's what almost one of the little version of these sits on top of a lithium battery. That's why you have a good result with lithium, because that lithium battery protects you from making mistakes. Programmable, Bluetoothable, so this will sit in place and keep everything protected. In through power distribution board. So this is a really sexy little compact distribution board. It's got the capability for 3 MIDI fuses and 4 automotive style fuses that enable me to then power out through the system. It's power distribution for the positive side only. I'll show you what I'm doing with earthing in a moment, but the existing van has 1, 2, 3 circuits already built into the van that I'll bring in through a low voltage disconnect and power through these main fuses. And I much prefer this. These are replacing some automotive style fuses which are prone to failure and corrosion, and they're not the best. So again, nice and compact, little cover. That'll sit up there, and then all the power will go through the little cutout that we made in the board. And then on the earth side, down this right hand side of the board, I'm going to run a Victron Bluetooth shunt again. So this is reasonably new product on the market. I've been a massive fan of Victron, you know, 702, 701 back in the past. The new Victron 712, which is Bluetooth, so you can have a gauge and Bluetooth. And now the smart shunt, which doesn't have a gauge, it just connects with your phone. I'm a bit of a phone nut. I always take my phone with me when I'm camping. I've got various other Bluetooth devices, so it makes sense that I don't need to drill a hole and run cable through the whole van. I can access my power, what I'm using, what I'm drawing, get graphs, get historical information. So this sits on the negative side. The negative battery terminal will come to this post, and then all of my loads that are powered for the van will come off this side, and it just simply measures the current draw through this shunt on the negative. I won't talk about that now, but current flows from negative, not positive. The old conventional theory was electrons flow from positive to negative, but they don't. They flow out of the battery in the negative side, and that's why we measure the negative side. So that'll sit pride of place on the bottom of the board, and then I'll actually run a cable up just to extend to an earth pin at the top, so that when I come out of my cables come out, I don't have to run silly cables. I can earth simply on the one point up here. Then I've got some little cable tray here that I'm going to put through the middle. This has a little cover on it, and that'll just make it all very nice. But to be honest, I've been really inspired by everybody. I've been looking at various websites and feedback from my sites, and there's a big movement at the moment in 12 volt to make everything look really tidy and really nice. I've been inspired by that. It's kind of 12 volt has gone a bit car audio. You know, we want to put our little Perspex panel over our DC charger and an LED to make it all look sexy. So, and I think that's great, and it's a wonderful thing. I think at the end of the day, remembering making it look sexy is really great, but just pay attention to the way you connect your cables, the way you solder, crimp, heat shrinking, you know, just making sure that you're using the right cable sizes, and you should have a pretty trouble-free install. So that's my basic board setup. I won't bore you now with all the mounting and the cabling and the crimping. We will do as I said, we've done the whiteboard lesson on how it was and what we're trying to achieve. And I'll come back and we'll see how it is at the end. Righto, well, I've got to tell you that was not a fun job. Anybody who's done an install like this will tell you just how many hours you'll stand here with a hunchback, crimping, stripping, heat shrinking, yeah, just playing with different cable sizes and cable lengths. It really is quite a job, and but anybody who's done it will tell you what a truly pleasurable experience it is. But nonetheless, we've now done it. It's taken me about probably nearly a full day of just laying out and cabling. This is the finished product. It's now ready to be installed into the van. I've basically taken that mess of wiring that is the factory van, reincorporated that into a nice fitted trailer plug now, that into a fitted multi-pin plug I should say, that will connect up, makes it look nice. This will go down to the original wiring. That'll come through the cable track into my new circuit board and fusing, which is now protected with MIDI fuses, I should say, MIDI fuses. So that's obviously much better than those horrible blade type automotive fuses with dodgy old yellow crimp terminals. Every one of those crimp connections was a failure point waiting to happen. So this is obviously a lot neater. It's now allowed me to expand extra accessory circuits into the van. I've put the cutout here, and in the van I've drilled a hole. I grabbed an old cigarette socket that I had, punched the back out of it, and that made a beautiful cable land. So I just had to drill a 30mm hole, put that through, and now this board will slot up onto that hole. And that'll make all of my cables that pass through into the van safe. They won't rub on any metal surfaces. So just always be conscious where you're passing cables through metal that you try and land it, or at least silicon it or something to prevent it from rubbing. Even convoluted tubes, great. My earth circuits, I've got a power side circuit over this side. My earth circuit lives on the left hand side. My battery positive negative cables will come to the bottom of the shunt. Everything else that I draw from this van will come off the load side of the shunt, and the shunt will measure the electron flow through it and how much current I'm drawing or putting back in. So I'll be able to graph all of the usage of my van. I'll be able to see all the current total draw, how much time I've got left in my battery. I've extended that earth point up to the top here with a little earth post and a cable. These terminals can get really, really busy when you're doing big installs like this. It also provides me an earth point for all my accessory circuits to come straight out onto an earth pin here. So that will just make the install that bit neater, and I haven't got cables coming down to earth. On the power side, obviously through my low voltage disconnector, again we've talked about the importance of those, through to the power selection switch, which gives me great flexibility, as we talked about in the whiteboard lesson, the ability to switch between the two, and then circuit protected to the battery, to the solar, to auxiliary, and obviously my DC-DC. So, I should mention the cable tray. I've now put labels on with my little labelling machine. That essentially slides over the top, has made this install look really tidy. I've been able to hide all of my cables in a little bit of 240 volt boys electrical cable trays. This is very commonly bought at electrical suppliers, and it just tidies the whole install up, makes it look neat. So without further ado, let's go and put in the van and wire it in place, and that should be job done from there. And we'll run a few tests and check with a few voltmeters, make sure we haven't got any hot points or issues, and then we should be done. We can go and enjoy a cold beer. Talk to you then. Well, there you go. That install's done, and we've been here in camp now for about 7 days using this system and given it a good little test with solar, DC to DC. We've had quite a bit of rainy nights and days where we had a high demand on the battery. So it's been great. It's a good system. As you can see, it was quite a tight install in that front boot, but it's actually turned out really well. Really like the GSL Electronics DC to DC charger. That's been great on MPPT solar and DC to DC charging. At 30 amps, it's given me good power capacity. I've been playing with the Victron battery monitoring. The Victron low voltage disconnect has kept my batteries protected this weekend. But I've really enjoyed the ability to switch between the different batteries with that marine switch. That's given me great flexibility, the ability to switch between the battery in the van or an accessory, auxiliary battery, second battery that we've hooked up. So we've had a great week. I got married this weekend to the beautiful Tina, and a big shout out to my gorgeous bride, and we're going to go and enjoy the rest of our week, and stay tuned for some more.